welcome to our channel. We are doing a series of 10th class mathematics. As a part of this, we are now in the chapter similar triangles. Already we have done two important classes where we have discussed some basic concepts about similarity, congruency, and what is basic proportionality theorem, what is converse of basic proportionality theorem. And in the previous class also we have done some most important example problems. Don't take the examples light, they are very important problems now. So if you don't watch those example problems, please do watch there. I'll give you the link in the description. Okay, if you are new to my channel, please do subscribe, and if you like my class, please do like and share with your friends. Let us get into the exercise 1 of your similar triangles chapter. Right, see here Nana, this is your first problem of your first exercise. What is that? In triangle PQR, ST is a line such that PS by SQ is equals to PT by TR. So see here Nana, he has given a triangle. So what is the triangle here? The triangle is PQR, and you have ST is a line such that, let us take ST is the line such that PS by SQ is equals to PT by TR. And also he told that angle PST, that means angle PST is equals to angle PRQ. So what we need to prove here? We need to prove that the triangle PQR is an isosceles triangle. The triangle PQR is an isosceles triangle. So this problem is very simple. Okay, so let us go to the problem directly. What is the given data here? First write the given data. So the given data is in triangle PQR, PS by SQ is equals to PT by TR now. Okay, that is the given data. And also what is the other one he has given for us? That is PST. Angle PST is equals to angle PRQ. Whenever you are doing some proofs, you should write the format here. That is, first you need to write given data, then you need to write required to prove, then you start the proof now. So what we need to prove here, that is required to prove. So what we need to prove here, triangle PQR is an isosceles. So write that down, that one. Triangle PQR is isosceles. Right now. So if the triangle PQR is isosceles, what happens? First of all, you think of that one. So see here, a triangle will be isosceles when two angles are equal. Now triangle will be isosceles when two angles are equal. So we will be trying to prove that angle Q is equals to angle R. Okay, we should prove that angle Q is equals to angle R. If you prove that one, then the triangle becomes isosceles. So how to prove that one? So start the proof here. So what is the given data given here? In triangle PQR, what can you say here? That is PS by SQ is equals to PT by TR. This is the information given. So here the ratio is given. So by converse of basic proportionality theorem, what can you say here? ST is parallel to QR, right? So by converse of basic proportionality theorem, you can write that ST will be parallel to QR here. So by converse of BPT, clear? And so what happens if ST is parallel to QR here? If ST is parallel to QR, then you can say that angle S is equals to angle Q. Why? Because both becomes the corresponding angles or not? Yes. So this implies angle PST, this is the angle PST must be equals to angle PQR. Must be equals to angle PQR here. How Nana? These are nothing but corresponding angles. This becomes corresponding angles. And also we know that angle PST is equals to PRQ here. So angle PST is equals to angle PRQ, which is again given information right now. This is given information. If you take this equation as 1 and this as equation 2 now. So if you take these two equations as 1 and 2, LHS are equal in both the equations, so RHS must be equal right now. So from 1 and 2, what can you say here? Angle PQR is equals to angle PRQ. Angle PQR is equals to angle PRQ now. So here both the angles are equal now. So angle PQR means this one and PRQ is this one. These two angles are equal now. Therefore, what can we say here? Therefore, the triangle PQR is isosceles. Right now, therefore the triangle PQR is isosceles. How simple is that? So first of all, take the ratio, and by converse of basic proportionality theorem, show that these two lines are parallel. If these two lines are parallel, automatically angle S and angle Q will be equal. Why? Because these two will be corresponding angles. Okay, now so these two will be corresponding angles. So this angle will be equal, and also we have given that angle S is equals to angle R now. angle S is equals to angle Q, and also angle S is equals to angle R. So what can we say here? So angle Q will be equals to angle R. If both the angles are equal here, therefore the triangle will be isosceles. So simple, Nana. So when I am teaching similar triangles, I will be teaching only some problems in a class. Why? Because you need to practice more, Nana. Practice each and every problem 2 to 3 times, then you will be having a command over the problem. Okay, and also whenever you are practicing the problems, keep the figure, and according to the figure you write the proof, Nana. If you by heart all this proof, if you miss any alphabet over there, then your problem will be wrong. So for that reason, draw the figure correctly, and according to the figure write all the given proof, Nana. So therefore the triangle PQR is isosceles, hence proved. Let us go to the next question. This is your second problem. In the given figure, he is telling that LM is parallel to CB. So see here now, LM, this is parallel to CB, and also LN is parallel to CD. LN is parallel to CD here. What we need to prove here? We need to prove that AM by MB. This is, observe the figure, Nana, AM by MB, AB, AM by AB, and also AN by AD must be equal. So just understand the figure like this. Just for your understanding, I have drawn there the lines. So why I have drawn these lines means, so this problem is like what we have discussed in our try this or do this right now. So here actually by basic proportionality theorem, in a triangle AN by ND should come, right? AN by ND must come here, but he is given AN by AD. We need to prove AN by AD. So this problem is somewhat different. So for that reason I am stressing more here. Okay now. So let us get into the proof here. How to go for the proof here? First of all, write the given data. So what is the given information here? LM is parallel to CB, and also LN is parallel to CD. LN is parallel to CD. And then what we need to prove here? We need to prove that AM by AB is equals to AN by AD. AN by AD. So see here how to solve this one. I am going to prove now. So in proof, so first of all, what is the first one here? AM by AB we want. So AM by AB is in the top triangle. If you divide the figure into two triangles, it is in the top triangle. Okay, so now you take the triangle ABC. Now you take the triangle ABC. So in triangle ABC, what can you say? LM is parallel to CB, right? LM is parallel to CB. LM is parallel to CB or BC. You can write anything. This is the given information. Therefore, what happens? By basic proportionality theorem, you can write like this: AM by MB is equals to, see here now, AM by MB is equals to AL by LC. AL by LC. Clear now? So by basic proportionality theorem. So right here by BPT, by basic proportionality theorem, it will be like that. But see here, we don't want MB here, but we want AB, right now. We don't want MB, we want AB. So for that reason, what I am doing here, you see carefully, this is very, very important step. See here, reciprocate on both sides. Reciprocate on both sides. So what happens now? If you reciprocate this one, this becomes MB by AM is equals to LC by AL now. Clear? So this is the very, very important step in this problem. Okay, already I told you when I am discussing the previous case also. And from this, after this, even though, see here Nana, I want AM. See here, in the numerator I have AM, so I want AM here, and I don't want MB, I want AB. Nana. I don't want MB, but I want AB. So for that reason, what I will be doing, you see here, Nana, add 1 on both sides. Add 1 on both the sides. So this is one more important step here. If you understand these two steps, then your problem will be completed. So what happens if I add 1 here? MB by AM plus 1 will be equals to LC by AL plus 1. Nana. LC by AL plus 1. So if you simplify here, what happens? This will be MB plus AM by AM, which is equals to LC plus AL by AL. Nana. Clear? So once you observe the figure now, MB plus AM, this is MB and this is AM. What happens if you add both MB plus AM? I'll get AB. Clear, Nana? I'll get AB here. So write directly, that is AB by AM. AB by AM is equals to, again you observe the figure, LC plus AL. LC plus AL. Nana. So see here, this is LC and this is AL here. So if you add both, you will be getting AC. So right here AC by AL. Nana. AC by AL. Okay, see here in the proof AM by AB I want, but I got AB by AM. I got reverse, right? So again you reciprocate here. This is also one more important step, that is AM by AB will be equals to AL by AC. You will be getting AL by AC you will get. Keep this as equation 1. Keep this as equation 1. Similarly, what you will be doing? Similarly, in triangle, now you take the bottom triangle here. In the first I have taken this part here now. Now I will be taking the other part here. Now I am going to take this triangle. For your understanding I am drawing like that, Nana. Try to understand that one. Okay, now similarly in triangle ACD or ADC, in triangle ADC, in triangle ADC, similarly in triangle ADC, again you should do all this process, but similarly we can write like this, Nana. So see here what happens here. In the top triangle it is AM by AB, right, Nana? AM by AB you got here. So here also you will get AN by AD. You will be getting AN by AD, which is equals to, here you got what you got here, that is AL by AC, and here also you will be getting the same thing here again, AL by AC now, AL by AC. So this is equation 2. So by applying the same procedure, if you want you can do 2 times, or similarly you write like this, you mention similarly, and according to the first problem proof write this second one now. Okay, second equation. So what happens from 1 and 2, from 1 and 2, what happens here? RHS are equal in both the cases. RHS are equal in both the cases. Therefore, you can say that AM by MB, AM by AB is equals to AN by AD. AM by AB is equals to AN by AD now. So this is our required proof, hence proved. Clear? So in this way we can solve the problems. Once you practice this part here, how this will come, AN by AD is equals to AL by AC. If you prove this one, then you can understand that you got this problem clearly. Take the triangle ADC, and from that you try to bring this conclusion, okay, as we have done in the top triangle. Okay, in triangle ABC. If you are new to my channel, please do subscribe, and if you like my class, please do like and share with your friends. If you have any doubts, you do comment in the comment section, and in the next class we will continue with some more problems now. Thank you for now. Let us meet in the next class. Bye.